Yeah? So it's on? All right. Oh, if it helps.
I hope.
Story of my life. Yeah, married to a database. Yeah. So, welcome back. Black magic. Yeah. Yeah, this is one of the late bone talks. Blend was something different, but I was told deployment stories are welcomed. So I'm the industry. So I'm always the guy that puts Faro into action. So and I like it because everyone should know how cool it is. Yeah. So well, the first advice is have inspirational quotes. So my first slide will just have an inspirational quote. I will refer to that a bit later. Why I wrote it there. And I thought maybe it's the best I pick up at Cagliari, because that was my last deployment talk. So that was about a system we did for the biggest German rail company. And it was about a mobility broker. In short, mobility broker is a system where you can say, I'm here, I want to go there, give me all the possibility with the price and all combinations. So it's a microservice architecture, of course, because it was customer driven. It has a message queue, and you can have bikes, cars, trains, whatever. So it was a project we did for Airbus, because they have a lot of expense for their employees to travel. And if they organize it, they save a lot of money. So we were in Cagliari, we were just demonstrating the whole development process, deployment process, quality, everything you do. And we were presenting the tech stack, including Docker Swarm and such. So in the meantime, we do our own project. So this was customer-driven. And 2 years before, we started our own product, which is called AptiveGrid, which I will present tomorrow. And yeah, so if you go from one project, just want to make the timer. If you go from one project to the other, you can just evaluate your tech stack. So what have we learned so far? And what should keep, what should we drop? So this was the tech stack we were using. So I think everyone does this. As soon as you start a project, 2 weeks after, you have at least 5 components, 5 open source projects, 5 server things, 5 database stuff. And then it grows. So yeah, it has grown. But, so we were looking in all the years and evaluating all the components. And I cannot say I was satisfied by most of these. So that's the reason why it has grown small. So just the list of components you usually have is a list of problems you have to solve. So if you make the list smaller, you should have less problems. So if you start it for real, there's the customer forcing you to stuff sim. Okay, so what's the biggest risk in projects? So the first thing that kills all projects is complexity. So that's what you avoid. The second thing is complexity, because that kills project. And the third thing is? Right. All right. Okay. Well, spoiler alert, we didn't manage to cover point 3 because it's in. But yeah, so let's take the tech stack, and then you're saying, well, we're looking at Elasticsearch. Elasticsearch is something all people put their events and data, and Elasticsearch can do aggregations, and then they put it on a dashboard. So Yeah, everyone likes dashboards. But if your product, the best point of your product is not having a dashboard, the first rule would be avoid using that stuff, especially at the beginning. If you cannot do this, postpone. In the best case, it's forever. If not, you just add it later because it distracts everything from the core product development. All right, RabbitMQ, and the other thing is console. I'll just explain. So RabbitMQ, microservices, you know, the big pattern. I'm not sure if it's still cool, but it was. So you have a message queue, you have different runtimes, and they send messages to each other to organize the whole thing. In the Broker stuff, there was one business logic component, and there was one microservice for the cars, for the trains, for the stuff. And if there's one, I want to go from A to B, you fire to all of the runtimes and collect all the results, and then you get it. So from a deployment perspective, microservices make sense. From a design perspective, no, because the software, so people always say, wow, if you do a monolith, it's spaghetti code, but if you do microservice, it's well modularized. And they talk about the same team. So, no. I would say, okay, this time, just don't microservice. So maybe it's come back later. Docker Swarm. So this was an experiment. Docker Swarm, Kubernetes, it's all over the place. We're just saying, okay, orchestration is always something difficult, and maybe it eases the work. But if it comes to Docker Swarm and Kubernetes, there's only one advice, and that's, yeah. So the theory is that you have orchestration. So the thing you will gain in Docker Swarm and Kubernetes is a huge amount of pain. So your infrastructure should weigh that pain. But that means you almost have 200 machines running or something. If you're only on 1 to, let's say, 5 machines, don't ever think about it. The pain you get is much bigger than the benefit you get. All right. Next one is easy. Monitoring. If you have a service that's not monitored, you don't have a service. That's the golden rule. So what's the value of the best product if you don't look if it's running? So if it's down, it's not a really cool project. So that was an easy decision, and an easy decision because that's not an integral component, an internal component. We just hook it on the side. So if that goes away, the product just runs. So Docker Swarm, if something goes wrong, boom, end of story. But monitoring, the uppermost is Prometheus for those don't. So we have a metrics library. You load it in Faro. Then saying, you want to know how many HTTP requests come in, how many responses go out, which status code they had, how CPU, I measured the garbage collector, so how many incremental full GCs have, external table, how many sockets, because I always problem that the external table, boom, it just grows, and then you leak somewhere, something, so monitoring is not discussable, I guess. Docker, I really would like to get rid of it, but it's really hard. So the misconception about Docker is the cool stuff is isolation. So it isolates CPU disk from everything, and you can form a decent service. The other part is it's a packaging of your software. So everyone is fighting isolation to use it as a package format. So, and then you have, it's not really the thing you want to use, but there's no alternative right now. Ansible is something, that's one of the products that really, over the time, it just got better. Just like saying, wow. Ansible, well, the really bad part about Ansible, it's YAML. Yeah, it's all YAML. We don't have to talk about this. But Ansible is, so we got rid of Docker Swarm because Docker Swarm is usually that you're saying, I have 10 computers, just make this my cloud and then deploy a service, and I don't care on which machine it runs. Just make it. And Ansible is it's a declarative way of doing exactly the same. You're just saying, okay, in a small project you can say, I want to have an all machine. I want an API runtime. I want a web server. So it's not a big issue. So that's for the yeah. So you don't have to understand it. The windows are moved together because of the beamer. So that's 5 windows. It's just a bit of configuration that does exactly the same as a Docker Swarm. So you have in the topmost, you have active 1, 2, 3. That's the machines. Then you have in the topmost, you have the association between the machine group and the role, and then it just goes off. So on the right side, you have the thing that installs Docker images, and below it's the server configuration for the load balancer. So in the end, you have a system where you have runtimes everywhere, and the load balancer is perfectly configured for all of these. It does more or less the same thing that Docker Swarm. So Ansible, except YAML. Well, HA proxy is the second tool, which is just an unbelievable good. It's as old as its syntax, so the configuration is really like, you look at it and say, really? But it's 20 years old, and it just does everything you ever dream of. If you run a web-based service, it's a load balancer that we use and we're really satisfied with. So, and finally, MongoDB database check. Wait. So, because I initiated the thinking process about, well, look at the tech stack, yeah? So, no, Docker Swarm, go away. We don't need you. And then the database is like, yeah, database. And I say, wait a minute. What's this thing about database? So that I told her already the story is this database, like looking on some simple databases that SQLite. It writes to files, and every time you say to people, database writing to files, they're saying, ugh, what's that? What's that old style stuff? And then you say, wait, how? What do you think it does? So in the end, every database writes the files. So that's the misconception everyone has. So that's the title of the whole talk, is because if you talk about databases always do something magical. So you give it the data, and then flowers, unicorns, and stuff, and everything is solved. But actually, it's not. So let's look at MongoDB again. We're looking at you. Well, the good part is simple document storage. You have one JSON object which can be nested at any level deep until it does not exceed 16 MB. That's the limit. You have, distributed commuting. Everyone is about distributed commuting. It provides database cluster. Everything looks good until you see every database cluster out there suffers the single writer problem. So there you say, the one thing you cannot say about data is you cannot write to the same set of data at the same time. That's something where magic ends and saying, this is the physics. You cannot write the same thing at the same time. And so even the MongoDB, if you have 10 computers making a cluster, there's only one machine where you can write to. So, and the rest you have all to do yourself. You can say, okay, if you read, go to this. But if you write, you go to this instance, which is really not what it promises all the time. So in the back, it was supposed to be web scale. So you just use Mongo, and boom, you can have trillions of users, and you don't care that there's only billions on Earth. And we have Voyage for it. I'm a maintainer for Voyage for a long time. So Voyage is really cool. It's an object graph serialization framework, which can work on Mongo. And for the base stuff, it's really easy. You make a class, you make a thing, and you save it in database. Boom. So no SQL, no schema, no nothing. It's just, it generates a serialized JSON, puts in database, done. So the not so good part is that after all those years, I think I'm finally done with JSON. So it's just, it's a blast from the past, I would say. I did in my early days, I was figured with Corba. And in Corba, you always had to write an IDL, an interface definition language. And it's the same thing since there, it's 6 data types. So come on. So back then, there was always, you have the weakest link, it's called C. Yeah. So if you have collaborative frameworks like inter things, you always need to go on the weakest link, that's C, so that you can, otherwise there's no way to communicate. So And I was saying, okay, JSON, I mean, it's so much better than XML, right? That's what we learned. But you have JSON, you have 6 data types. There's not even a data type for date and time, nor date. Everything you have to do, you have to serialize to string and numbers and booleans and nils without having the chance to transport any metadata to say what it is supposed to be. So it's all proliferating implicit knowledge if you code. It's like say, oh yeah, I know it's a date and time, yeah. So, but that's not a definition of an API because it's not negotiating. The point that Mongo uses BSON, which is a binary JSON, it has a few more types, including date and time, but date and time does not have time zones. So everything you write to database will be converted to UTC. And I already told, so I can put my birthday, 11th of October, in the database and read it back, and it's 10th of October because it's just UTC, read back, and Smalltalk cuts off the hours. Then you have, well, you're 1 day older. Congratulations. MongoDB kept up. It's actually the same story than MySQL in the 90s. Like say, MySQL, like, nobody needs transactions, blah, 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 it's making slow. And then later, what did they add? Transactions. Same story for MongoDB. It was web scale, and now it needs transaction. It has transactions. But the driver we have, which is called MongoTalk, does not support this. So we cannot use that out of the box. What I told already is a single writer versus sharding. So the fact that you cannot write to the same set of data at the same time, you can solve in a different way. So either you have a single writer saying, I stack up all they want to write at one point, and then I just sequentially write that. Or you do something like sharding, which is a virtual partitioning. It's just saying, whatever data I have, I make some circles around it, and I'm saying, for this part, you write, for this part, you write. So you distribute a graph by virtually partitioning, so you can have more write actions. So that's all the MongoDB and all these databases, Postgres and stuff, they all deliver to this day. And the final stuff is that we have really, well, we can talk about the collection protocol in Smalltalk, but I think we like it. So, and then if you go to a database or something, you have always to face yet another query DSL, which is, well, SQL is kind of nice from the expressive kind of thing, but it's always, if you leave Mongo, we have just like super big nested JSON stuff, and it's a drag. And yeah, I stopped. So, and the project we're doing right now at ActiveGrid is kind of an online database. And so we have now the situation I was saying, there's an impedance mismatch, saying I have a database that cannot really do types with a transport format which can do less of these types, and we want to have a lot of types. And I don't want to have all this hassle all the way, saying, okay, as we were really inspecting our tech stack, we're saying, well, as there's no unicorns and no magic, so what do you really need for a database? So is it really magic you cannot do? Yeah? Or is something you can achieve yourself? All right, so the one thing you want to have is ACID transaction. ACID transaction, in short, is just a really sane way going from one sane state to another sane state without being interrupted. There's included something like if the system goes down. So the first A is atomicity. So meaning if you have a lot of write stuff to two objects, either everything is written or nothing. So that's a guarantee. It's just like the equal we heard in the presentation from the VM. So at one point you need to know what is atomic. Because if you don't have something atomic, you cannot reason on top. Because it could always be, that's how race conditions grow. C is for consistency, that the things the database writes is defined and really predictable. Isolation is something that you, especially if you have object graphs, you're saying you have one object and you have another object that's being referenced, then to be efficient, you won't load all of the object graph into the image because that would be slow. So what we usually do, because in Smalltalk it's easy, you load the direct result of the query, and all references have proxy objects. Proxy objects that know database ID or whatever, that if you call does not understand on the proxy, just say, wait a minute, I know how to get the real object, and then you go to database, get the object, and then you just take the message from does not understand and send it to that object. So that's the basic stuff, how we roll in Smalltalk. And then you want to have the assumption, if I read the first object, and then I take 5 seconds, and then I read the next object, that it has not been altered in between. So you want to have the graph at one point in time when you started to query. And that's what isolation means, that you say, you know, no matter how many objects you get from the database, you get it always at the state in one point in time. Durability is something which most databases use with a transaction log or a journal, that you say you have a double book check, so you write it first in a file, and then it's applied to the database, because if then the system breaks down, you still have it at one place. Either you don't write it to the journal, then it's just like pretend nothing happens. But if it's in the journal and the database crashes, you reboot, and then it's saying, hey, I have the version number, journal, tell me, you have more, so let's replay. So they replay the rest of the journal, and then you're still at the same gate. So going from one sane state to another. So that's what you want to achieve. So what you need for this, if you go for, so SOIL is the working title for the OO database in disguise. And so I didn't get the requirement. I just want to have a database which writes to local files right now. So in order to have ACID transactions, one thing you need is called regional file locking. So that's in SQL databases, it's row level locking, it's the term. It's just saying that if you have one object and it's stored from byte 24 to 48, you want to lock that region. So you don't want to lock the whole file for everything, because if someone writing to another object, why care? Regional file logging just say, this object from here, I log this, and then I'm having an assurance from the operating system that no one else, well, none that also cares about logs, especially in Unix systems. But if we're talking about the same application, so you look at the log, and then you log all the objects, and then you can go to a sane state. Serialization, materialization, it's rather easy because we have a memory layout, and writing it to disk will be some other byte format. So in the best case, what I learned from Gemstone is, I didn't know before that you can have the same layout on disk as in memory, and you can just read it in. So yeah, it was just mind-blowing. I mean, it's obvious, but with all these technical stuff, we always forget that sometimes things are easy if they're simple. Yeah, finally, you need a B-tree implementation that is just one way, or the way, of making a search quick. B-tree, binary tree, is just that you have, if you have a magnitude, something which is audible or sortable, then you can just search by, if it's not the first and not the last element, just cut the hole in the middle and see if what I'm looking is bigger or smaller. And so you have log n, you have just a lot less step. For 1K, you have 10 steps in order to find it, guaranteed. So everything can be, so the usual stuff a database will do is a linear scan. So just meaning first entry in the table, next, it will check every single row, object, whatever in the database. And binary tree just makes it a lot faster. So the only thing you have to do is from the object, like a hash in a dictionary, you need to make a number, something that is sortable out of it, and that you put in a B tree, and that will be. So in most databases, you have multiple indexes because the instance variables or the criteria you search and the combination is, the index depends on this, because this hash thing you create for, if I have an object customer and the first name is Norbert, and I want to do something like in SQL, where first name is equal Norbert, what we also see in Smalltalk, you would make an index for that first name. I'm saying, okay, we can alphabetically sort, so you can use it in a B tree. So we take all first names of all objects, put it in a B tree fast. So that would be the goal. And the reason why this is coming to life is because we thought we have an open source library that does this. But sadly, that's not the case. So I thought it was open source, but the original author Just contacted means that that's wrong. That's something in the middle that did something which was not really legal, and so we don't have it, but I will do it. So, well, I'm not a database expert, I'm not, so it's a journey and I really enjoy this. I don't know where it gets, but there is, so if it comes to serialization, materialization, I would say, okay, we have fuel already, we have a good one. So that's a good part of the database, is just how you serialize everything. And if you take fuel, you can even serialize clashes. So if you want that or not, maybe another story. So that would be the thing. But then you have a database that's writing to your disk. And everyone I was talking to is saying, how can you scale that? That's not, you need a real database and stuff. And I'm saying, wait a minute, yeah. So yeah, it's writing to local files, but why do you need a product for this? Yeah, so is there not something, so maybe the application drives performance, drives what you do. And so in the current product, that what I'm telling now is just the thing, how it evolved over time, just saying, what do we really need? The first thing is, that's a typical setup you have. So so I need to do everything in key pointer, that's why it looks really not so good. But so the rectangle is a machine, and the P is, so that should be a P in the small square, which is faro. So this is a runtime, and on the bottom there's a disk, and there's a DB file. So that would be the usual setup. So you take your faro, put it somewhere, it writes some files to disk, and then you have a web server or something. You use that. So, but what would be the approach? So if you have one faro, it's rather easy. So you would have to open always the database for the requests and stuff. And I'm saying, okay, we can make that database open and we keep it in memory as long as we want, until we need a second faro image to spread the load a little bit. So if we have file locking, so the problem of multi-images we resolve by file locking, because that's the promise you have. If you have multiple runtimes, you can just say, all try to go in a file system, and that's kind of a semaphore. It's like saying, even if I'm not in the same system, I can acquire a file lock, and if everyone does it, it acts exactly like a semaphore, because it's just saying, it's not blocking, we're saying, wait, you're not allowed to do that. So, but yeah, so in the end, everyone that does a service saying, but what if I become Facebook? Yeah, so it's always some, so don't worry, you won't. But you still want to have something that scales. And to my experience, no matter if I'm a database expert or not, there's only one really good solution for concurrency in a graph, and that's partitioning. So that's the one thing you can always have for free. If you're saying, I look at so usually we're saying my product, 10,000 users, they have data and stuff, and I'm saying, oh, it's concurrent. I'm saying, wait, but isn't each user supposed to be separated from each other user? And then you have, so then you cut it in 10,000 pieces, and then you have 10,000 graphs. So, and that means at least, so as long as two different users write to their database, you cannot have a problem, because they just write to completely isolated stuff. And that's what we do in ActiveGrid. So every single user that registers gets its own database. And in the parentheses, you see the file size. After you created a database on disk, it's 4K. I'm willing to spend that, because if I do the math, it's 1 million users, it's 4 gigabytes. I'm saying, okay, state of the art, I think it is neglectable, because you can barely install a Java runtime or anything which is below that. So, and then you don't even have a user. So yeah, so now we have 8 faro images, and we have a lot of DB files, and I'm saying, okay, keeping open a database is now a bit difficult, because then I need to predict on which the request for this user need to be on the same faro image. But how? So then you say, okay, we're thinking further. We want to even scale over one machine. So I'm saying, yeah, so we just say the guy in the bars just say, oh, if your local files, you never exceed one machine. Yeah, but there's always a low-hanging fruit. And there's something called a distributed file system, which so well, it's not more complicated than most other components, and cluster FS that we use is rather easy to say. The only criteria I researched was it's 12 years old. Red Hat bought it at some time, so it will be supported for the next few years, and it will be. So, okay, next thing is we have multiple machines. There's a distributed file system, and this one is a replication. That means that on all machines, all files are present. So there's different setup. You can spread it, but for the simple setup, you just say, okay, for failover, for backup security, replication, so it's especially if you don't have a lot of users, it's the best way to do. But then, if you have multi-machine setup, and we all know the CAP theorem, you cannot escape the consistency, availability, partition tolerance, because when you have distributed computing, either one node dies, or you need to calculate the time it needs to travel from one node on another, so you cannot guarantee if on two different machines they lock the same file, the time it takes to travel between the machines just breaks the whole concept. So file locking across the network is not reliable. Well, you can do this, people do this, but I won't, because I just know it's like any other race condition. If it can fail, it will fail, and you don't want that. Even if you have transactions, which basically should assume that at least the database does not corrupt it. But, well, we want more of that. And we learned a lot the last 30 years, so let's try something more. Saying the biggest problem I had so far was identifying the user or mapping a user to one Faro image. And what we do is a stateless service. Stateless service is the definition that you don't use cookies. So a stateless service just means that every request, every HTTP request consists of all information you need to solve the problem. And that removes all the problems you have to use. You don't have to use cookies because you don't have to store any state. Every request, it's just you have all, like in Google, you have these long URLs, because for us it's in Adaptive Grip, you're a user that has spaces, that has grids, that has entities, and then you have users ID, spaces ID. It's a long thing, but who cares? So any URI can be 4 or 8K, depending on the browser. So that's not a problem, but you remove all the cookie and additional complexity. And then the middle line, that's one of HA proxy, because it can just do nearly everything. It's called stick table. You can just say, okay, create an in-memory table, and then you're just saying that's a weird syntax for take the path and then split it by word, by slash, and take the third. So yeah, I told it's a more ancient approach. So if the basic API users, which is the normal database we're using, so just, and that would be the red ID. The third from the beginning would be the red number. So take that number and put it into your stick table. And then there's something, okay, and then remember to which of the Faro image you send that request. And every time an URI comes with the same number, you give it to the same Faro image.
Norbert, this is forever, not so session-based. It's I'm a user.
Stay tuned. Huh? Okay. Yeah, thank you. Well, that's, the green one is wrapped up. So what happens and why I'm doing this? So Keynote does not have a cloud shape, so it's saying it's a cloud shape. So that's the internet. And then there's a request with these API users 1, 2, 3. So the HA proxy makes the table 1, 2, 3, and then it chooses any of the Faro images and proxy that to that, and then it makes in the table, oh, I use this one. Yeah? And the next request, always the same Faro image, the same Faro image. And now your question. So if it dies, no, it's not forever. So it's as long as HA proxy is running. So the thing what you should note is that it also has the black lines between the proxies on the machines. They keep connection and they sync this table between all load balancer instances. So every machine has the same table. No. So it's just the blue ones up there is machines, and there's H proxy, and there's black lines between. It's just the 1, 2, 3 is on each HA proxy. So it doesn't even matter on which machine the request comes in. So in the end, it points to the same Faro instance, and now the Faro instance chooses 1 dB for that user. It can just open and cache all the database open because it knows next time because the ID is a data partitioning. So because every user has a different ID, every user will point to different Faro images, and it will hold as long as Faro HA proxy is running or one of the Faro dies. So if that Faro image dies, there's an option called redispatch saying, okay, the user didn't notice, so should just try another Faro image. And then he rewrites that table saying it just chooses, and that would be the green one, for another user or for that same user, and then it just uses another Faro, and then saying, so let's pretend it was always like this. And the only penalty is the new Faro image need to open the database and then cache it. So what we do, cache it for 15 minutes of inactivity. So if the last request was 15 minutes ago to that database, close it. Because there you just keep it in memory, and when they get stale, you just close them. And so you have an average of 10 or 20 databases per image. But the most important stuff is that there's no relationship between a user, a runtime, a machine, and whatever. So everything establishes itself, and so you have the perfect failover scenario. So when I'm doing a Linux upgrade, for instance, I just reboot any of these machines, and nobody notices. Yeah?
Do you have a lock to avoid having the same database open by different images?
How? How do
you know that, that the other...
Is this some kind of this magic there? Yeah.
You know that it was not opened by another one. So this is, you have it somewhere.
Yeah. Why should it be opened by another one? So
how do you detect it's there? It's not responding, you have timeout, and then you say...
HA proxy. So there's a protocol that a load balancer, so it keeps the connection to the one, and then every couple of seconds it makes a TCP check. Are you still there? So, and if it goes down and there was no request, it just say, oh, this is gone, so it removes it from the list of distributable stuff. Yeah? So, and the other thing is if the Faro image, what is more likely is it dies while making the request, because if there's no request, there's no reason for Faro to die. I mean, it can make, but that's usually not be done for Faro images. So yeah, so that's this option redispatch is just saying, in case of error, just try another Faro, which is a bit strange because if you have a really severe error, where the request kills the image, you can make just poof, 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 poof. But yeah, not forever. So otherwise you would kill all of these, but it kills 3 of the Faro image. But the point is that there is a way that external user notice that there is one 503 or something, but usually nobody should notice because the whole monitoring, there's even one level high because the load balancer, I want to sleep at night, yeah? So I'm saying, so I made a setup of 3 machines that can all do the whole job, but who selects which machine to use? And that's usually DNS. So you have to pick one of the machines. And what I do at my provider, because it's all clickable instances like 15 euro, like it is. And then they say a load balancer, and then they have a load balancer, and I have all these HA proxies in there, and just saying, okay, now it's their problem. So the DNS goes to there, they choose any of them, and as the tables are synced, it doesn't matter, it just distributes. But it ends in being in the same Faro, and that is where the caching potential grows. So there's concept I'm thinking about recyclable transactions. I really like the name because it sounds so stupid at first. Just saying that a transaction is an assurance that you can detect conflicts, but a transaction is also an object cache. So you load all the stuff from the disk, and then you keep it. And as long as there's no write to the database, it's the same thing. So you can just reuse or recycle that for another request, and then you have all the objects. So we had that discussion yesterday. The biggest duty of every database is avoiding reads. So the databases that try to mess up with writes are always the one that corrupt, because you need to write to disk, otherwise it's not persistent. Yeah? So you cannot, so it's Linux, all this stuff. You can't hardly avoid that, but you can avoid reading it all the time. If you need the same stuff, you just avoid saying, I have this in memory, I have this in memory, so don't need to go to, and then you have all the disk. But the most important stuff is that the flaw of the architecture is that it's pinned to one Faro image, so if you have a really big customer, it will become more difficult because the architecture is this spreading. So horizontally, you can spread this for, I would say, easily for 1 million users, because you just have then 20 machines which are high-powered and stuff, but the size of a Faro image. So you would then go on the same machine, file locking works still. So you can, so HA proxy can really do a lot of stuff. If you're a big customer saying, all the 8 Faro images now do just for one customer, and as they do file logging, they still don't stump on each other, on each other's foot. So, okay, that's the whole story. And the learning is that we're talking all the time in Faro, like saying, what needs to be in the VM, what needs to be in the image, and then you see, oh, even garbage collection, everything is so application specific, because you cannot know what is the best strategy to do all of this stuff. And then at one point I'm saying, wait a minute, everyone is saying, frameworks are shit, libraries are good, because you don't want to be caught into it. And then I look at the database products and I'm saying, what are you? You're a framework of persistency, and either this is tuned in a way it's preferable for me, or I can come up with an architectural approach to persistence and scalability which matches the domain model pretty much. And that's why I think that this is scalable and can, so for us, it's not a general approach, so for each business logic or business model you need to have the decent approach, but for us, it's working, so persistence, it's better if we have these few components and arrange it in a way that it really works as we want it. So architecture is the way of achieving scalability and performance, because usually a foreign product forces you to have interface communication negotiation, which is not in sync with your business model, so you also lose a lot of stuff. So actually, and what I wanted to prove, writing local files is not a blocker. It's not bad to write local files. It's good, yeah? So it's nice, cozy, and with that approach, and that's what I always do, every single developer in my company can, within 2 minutes, set up the whole stack, the whole product in his machine for testing and developing and stuff. So, and that's the other thing, yeah? So that you have. And writing local files, not to having, and that's, well, James sleeping, it's good. James, that's one of the reasons Gemstone is probably not the easiest to use. So that's a clear benefit. Yeah, and then the last point was the most important stuff was pinning, like saying, not like the web pinning, like saying a cookie where you force everything to one thing, and if that dies, everything is lost, but having a kind of pinning that can survive a failover that you then pin again. So you have a pinning as an option for caching, for improving scalability, but if it goes down, no problem. So there is no, you don't depend on the pinning, but the pinning enables stuff. So that's the end already. And I hope this was not too boring and understandable, how we can not just try to delegate complexity, because it's not possible. And think about the main model and how we use it, Smalltalk. So we have so many possibilities and really can apply in a really clever way not to use any of these promising big products out there and still achieve more or less the same or even more. Any questions more?
Can you say a word about how you deal with testing?
The question was if I can tell about testing in the whole product. So we have more or less the same workflow.
How do you test scalability?
Yeah. Okay. Yeah. So, I mean, I'm a Linux admin since '93. So I know it's really hard to test scalability. But even if you have enough money to book all the machines, you need to do someone. So even friends of mine, they have Stormforger. They have a company doing load tests like this. But still, they also have the same thing. So if you just fire a lot of request stuff, you're just hitting every cache path and not a really business logic. So it's really hardcore to make scalability tests because the variability of the data needs to be so high that you not just bump into any cache. Yeah? So, and that's really hard to do. So, and as an admin saying, I mean, I'm stupid or brave enough to not use an established database, but doing my own stuff, which is insane. That was about breaking the rule at the beginning, because the rule I learned, you don't do your own database. I was saying, I do my own database. Yeah, get over it. And so the thing is, that's the major point about monitoring is, so monitoring serves two purposes. The one thing is actually seeing that your service is running. And the other thing is projecting, because monitoring stuff, you can always say, show me the last 30 days. And then you see a line of requests and disk space and everything. You see it raising, and then you're saying, oh, okay, I see it coming. Huh? So, and then the other thing is that scalability is really, well, if you see in system thinking, so you can use in 1,000 clients you can test. And it can be that in 1,001 it breaks. Because, so what I learned in Linux system, and I did really big ones, is really, it's keeping the balance. It's just one component that it goes out of scope and it pulls everything down. So yeah, you can then I have only 1,000 customers, then you test for 1,000 customers. But if you then think 1,001, it's also, it's not. So it's really hard, yeah. So we don't do this. So I'm just monitoring closely. So now we have 6 Faro images, and within 1 minute I can make that any number of Faro images. So we scale, and I also have to figure out the optimal number of databases per image, requests per image and stuff. That's all pretty, with the external table, semaphores and stuff. I'm doing this for years, always looking like, oh, well, 400 open sockets, looks good. So the customer of our Telecom in North America, they do 800 requests per second. And it also works even with a heavy Mongo load. But there's only, so you never know. And then the VM somehow, you have a OS threshold in the memory. You know, the Linux model is like, come in all the blame, and if you're too heavy, I shoot you and throw you on board. So there's so many, so memory overcommit, that there's so many things that you're saying, okay, so just because a fork doubles the memory you need, you have a memory overcommit because you don't want to spend it only when you then really need it. But that's kind of a bookkeeping. You give more memory than you have. And if then it gets sparse, you just shoot any process. You're just saying poof, poof, poof. And then, but that's not something reliable. That's monitoring. You really have to balance out the system. So, and then there's always that point of saying, there was one request, they got over the memory threshold, then the GC picked in, then it gets slowed down, then it couldn't make the request, then the other image got this request too, and then it goes down. Because if one goes down, the others need to compensate. Then goes another one down, and then that's the thing how systems think. So yeah, I would really like to have scalability tests, but it's really hard to do. And we still have to do a project. Okay. Gracias.